Welcome back! Let's build up a Sankey diagram to visualize the complex energy system of, for example, the European Union. We take the energy system of the year 2023 as a reference here. You can do this Sankey diagram for any energy system around the world. Sankey diagrams is a data visualization technique, or also called a flow diagram, that in this video lecture emphasizes on the flow conversion of energy carriers from winning energy carriers up to the consumption of the energy carriers. The width of the arrows is proportional to the amount of energy distributed, converted or consumed. So let's start. Let's consider the fossil fuel coal. Coal forms over millions of years from dead plant matter in swampy environments. When the organic material, peat, gets burned by sediment, under pressure and intense heat, it transforms via various phases into coal. Heat and pressure squeezes the water and gases out of the peat. This process is called coalification, concentrating the carbon by removal of water, oxygen and methane. The total primary energy source coal available in the European Union depends on the production, export and import. The production of coal within the European Union refers to the mining of coal, which can be surface mining for shallow coal deposits and underground mining for coal located deep below the surface. Export refers to the mined coal in the European Union that is exported to another economic zone outside the EU. However, the figure shows that the EU has a net import of the energy carrier coal. This means that the import of coal to the European Union is larger than the export of coal out of the European Union. Some of the primary energy source of the coal is converted into a secondary energy source like electricity. This happens in a coal-powered electricity plant or coal-powered combined heat and power plant, CHP, as shown is this figure. The generated electricity is distributed to be consumed in the various sectors of end consumption, like the residential sector, or the sector industry, or the sector of transport, and the other sector, the miscellaneous sector, that includes in this example the energy consumption in the agriculture sector, the public sector like universities, and the military, for example. As discussed in the previous part 1 lecture of the energy system, some of the electrical power is lost during the transport and distribution via the electricity grid, as shown here. The primary energy source, coal, is also directly used in the various sectors like industry, residential and other sectors. In addition, coal is used to be converted into another secondary energy source like heat in combined heat and power plants and in district heating. So starting from the primary energy source coal, you can see that there are various conversion and distribution paths to follow and to arrive as functional energy at the end consumer, which are categorized here in the important sectors. The heat generated by nuclear fission, splitting of uranium atoms basically, in a nuclear plant is a primary energy source mainly used to generate the secondary energy source electricity. In the nuclear plant, the generated heat boils water, creating steam to spin turbines that are connected to electrical generators. We continue in further constructing the Sankey diagram for the European Union energy system by considering the second fossil fuel, gas. As you can see by the blue arrows, the supply of this primary energy source depends on the net imports of gas from outside into the European Economic Zone. This includes first natural gas imports via pipelines, where Norway in 2023 was the top pipe gas supplier, and secondly liquid natural gas, where the US was leading the LNG import in 2023. Gas winning in the European zone takes place in primarily the North Sea, the UK and the Netherlands, and in the Netherlands, the Groningen fields. However, the latter production is rapidly being phased out due to seismic concerns. Part of the primary energy source is converted via the power plants and the combined heat and power plants and district heating into the secondary energy carriers as electricity and heat again. Gas is directly consumed in the sectors industry, the residential sectors, and the other sectors. Let's consider the third fossil fuel, oil and its corresponding oil products. Here, oil is referred to as crude oil, which is the raw, unrefined fossil fuel extracted from the underground reservoirs. Crude oil is a liquid mixture of hydrocarbons. Oil products are the finished products like gasoline, kerosene, diesel, heating oil that are derived from processing the crude oil. This happens in the so-called refineries. As you can see, the economic European Union zone heavily depends on imports of crude oil, indicated by the energy carrier flow in black. The supply of crude oil to the European Union in 2023 was led by the United States of America, Norway, and Kazakhstan. Know that after Russia's invasion into the Ukraine, the European Union drastically reduced oil imports from Russia. The top EU crude oil production countries in 2023 were Italy, Denmark, and Romania. The refinery activities to convert the crude oil into oil product took mainly place in Germany, Italy, the Netherlands, and Spain. The largest end consumer for oil products is largely the transport sector, and in the sectors industry, the residential sector, and others, a small amount of oil products are directly used as well. As you can see, the European Union has a significant export of oil products or buffers these in fuel bunkers. Let's focus on the power plants in which primary energy carriers are converted into electricity. In the conversion process, not all chemical energy stored in gas and coal, nor the all nuclear thermal energy can be converted into electricity. As discussed earlier, losses occur in the conversion. Conversion efficiency of modern combined cycle gas turbines reach over 60%, while the best coal plants reach conversion efficiencies of 40 to 45%. And about 33 to 37% of the nuclear heat is really converted into electricity. Light gray energy flow over here represents the conversion losses in power plants and combined heat power plants as well. Finally, we arrive at primary energy source based on renewable energy. These include mainly hydroelectricity, wind energy, solar energy, and biomass energy. Hydroelectricity is based on the conversion of the pressure and gravitational energy of water behind dams into electricity using Francis turbines. Wind electricity is generated out of the kinetic energy of wind incident on the wind turbine, whereas solar electricity is the conversion of the radiant energy in the sunlight into electricity using semiconductor-based photovoltaic solar modules. Biomass energy is making use of the chemical energy stored in biomass generated by the natural photosynthetic process. So if we consider the total energy system and use the basics we have learned in the previous video lecture, I have highlighted here all relevant primary energy sources for the European Union. It reflects the winning import and export of these energy carriers. In this slide, I highlight the conversion of some of the primary energy sources into the secondary energy sources like electricity and heat to be consumed in the various sectors. And finally, I highlight the distribution transport of energy carriers to the end users and the consumption in the various sectors. And this Sankey diagram is a simple visualization of the energy carrier winning, conversion, distribution, and consumption in the complex energy system of the European Union. Using this Sankey diagram, we can play for instance, with the concept of efficiency which we introduced earlier in this course. Let's consider the energy value chain with final energy consumption functionality of powering a car with a combustion engine. Let's assume that the efficiency of winning the crude oil is 95%. And the conversion efficiency of producing gasoline out of the crude oil is 98%. The transport efficiency of gasoline from the refinery to the end consumer is about 95%. And the conversion of the chemical energy in the gasoline into functional mechanical energy that moves the car is 25%. Note that in a combustion engine, most chemical energy in the fuel is lost as heat. This results in 95% times 98% times 95% times 25% in a total chain efficiency of 22%. This means that 78% of the chemical energy in the primary energy source crude oil is lost in all these process steps. Let's consider an alternative route with the same end-user functionality, except we consider an electric car. We assume that electricity is generated in a coal plant. Let's assume that the efficiency of mining the coal is 95% and the conversion efficiency of producing electricity out of coal in a coal plant is 40%. The transport efficiency of electricity from the coal plant to the end consumer is 90%. And the conversion of electrical energy into functional mechanical energy to move the car is 90%. Note here that an electrical motor is far more efficient than a fuel-powered combustion engine with an efficiency of 25%. So this results in 95% times 40% times 90% times 90% in a total chain efficiency of 31%. This means that 69% of the chemical energy in the primary energy source coal is lost in the entire processes. Now let's finally consider an alternative route with the same end-user functionality, and the kinetic energy of wind is being considered as the primary energy source. We assume operation conditions such that the conversion efficiency of a wind turbine is 40%. The renewable electricity is a secondary energy source in this case. The wind turbine is the power plant, and therefore we assume the conversion here to be 100%. The transport efficiency of electricity from the wind turbine to the end consumer is again 90%, and the conversion of the electrical energy into functional mechanical energy to move the car is again 90%. This results in 40 times 100% times 90% times 90% in a total chain efficiency of 32%. This means that 68% of the kinetic energy incident on the blades of the wind turbine are lost in the process. Nevertheless, it has a higher chain efficiency and a significantly lower CO2 emission along the chain in reference to the other example using electricity generated in either a coal plant or using a fossil fuel like gasoline. After these video lectures on the energy system, I hope you now understand what are the essential processes that define an energy system, like this energy system of the European Union in the year of 2023. That you are able to distinguish between the primary energy and the final energy use. And thirdly, how is the energy efficiency of an energy system defined? We have given various examples in these videos. And lastly, understanding a Sankey diagram that represents the processes and flows of energy carriers in an energy system. In the next video lecture, we will use a different approach to analyze the energy system, the energy balance. We will use this energy system of the European Union in the year 2023 again as an example to build up an energy balance. So see you in the next video.